Alright, so we're going to solve diameter of binary tree. As you can see, it's an easy question. But then, is it really easy like that? So let's see. So given the root of a binary tree, return the length of the diameter of the tree. So first of all, where is my paint? Yeah, this is where I'll be solving it. Okay, cool. So the diameter of a binary tree is, they said the diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the roots. The length of a path between two nodes is represented by the number of edges between them. Okay, so they said that the length of the path is represented by the number of edges. So we're supposed to find the diameter of the binary tree, which is just the longest path between one node to another node. Looking at this example, the longest path will go from 4 to 1 3 or 5 to 1 3, and the amount of edges are 1. So you can just count this like 1 2 3 or 1 2 3, right? So this the longest, the diameter of the binary tree will be 3, which is 3. For this example, 1 and 2, so if I say I want to draw 1 and 2 now, yeah, of course. Why is it not moving? I'm using it as a mouse. If I say I want to draw 1 and 2 now, I'll be doing 1 and 2. You see, the longest is actually the the diameter will be 1, which is, 1 edge, 1. So how do we solve this kind of question? How do we write a code that can determine the diameter? This is a trick question. So when we talk about tree, most of the time we will want to transverse through the tree using a breadth first search or a depth first search, right? I'm just going to partition this so that I can manage space well. Yeah, so we want to do depth first search, breadth first search, right? And we'll take this example as a test case. 1 2 3 4 and 5. Yes. Okay. So what we might want to do is we want to basically find the diameter, which is the question. But how we want to solve that is we want to use a depth first search. So we want to take for us to find the longest, the diameter, the longest part, we need to take a node, and then we need to know the longest. If we take this node as a reference, we need to know the longest part at the left, then add it to the longest part at the right. That will basically give us the longest. If we take node 2 for example, we need to know the longest at the left plus the longest at the right. That will give us the longest for this node too. I don't know if you get me. So basically what we want to do is we want to go through all the nodes, but we want to take the longest. We want to know at that node, we want to know the longest at that node. So if we know the longest, if we can go through all the nodes and find the longest at that particular node, we'll be able to know the longest. So we'll be able to know the diameter. So first of all, we should have a variable that will be updating. So for the variable would be updating. So the variable will start from 0. We'll check 4 and find the longest node. The longest node between 4 and 4 is 0. So we go to 2. We find the longest node. The longest node of 2 will be the longest node at 4, which is 0, which is actually 1 actually. So anytime we find the longest node at a particular node, the diameter at the particular node, we'll add 1 to it. So the diameter at 2 will be the longest at the left plus the longest at the right. The longest at the right would also be 1. So for 2 is going to be 1 plus 1, which is 3. No, it's going to be 1 plus 1, which is 2. Sorry, which is 2. Then for this one, for node 1 will be the longest at node 1 will be the longest year plus the longest year. The longest year is actually going to be 2 because of it's either going from year to year or from year to year. It's going to go from year to year or from year to year. So this is going to be 2 plus 1, which is 3. So it's going to D is going to be replaced by 3. Yeah. I'm going to explain that again. It's kind of, I think I kind of confused myself a little somehow. So let's use a different example. Let's use 1, let's use 2, let's use 3, let's use 4, 5, let's use 6, let's do 7, let's do 8. Okay, so in this situation I know that if I look at it, the longest should be 1, 2, 3, 4, 5. The longest should be 5 in this manner. In this nice, I can change color in this manner, right? But solving it with our algorithm, what we do is we go from we'll be using a depth size. So a depth size will eventually start from the list node. We go from the list node to find the diameter of this. Now, so first of all, we have our variable d and say that we first initialize it as 0. So we go to our lowest node 8, right? 8, 9. The maximum for our lowest node would be the highest diameter for our lowest node is 0. For this is 0, for this is 0, for this is 0. So for this is going to be 0. Yeah. So 7 for node 7 is going to be the highest at 8 plus the highest at 9. Now, once we get our diameter at node 8 as 0, we would compare it and get the maximum. But when we get 7, but then we also want to return, because of we're using depth size, so we want to return to the node that called it. But what we want to return, we don't want to return the maximum diameter. We want to return the highest between the left and the right. So the highest between the left and the right would be plus 1, because of when we count this node too. So this will return 1. That 1 is the highest at the left. This will return 1. That 1 is the highest at the left. So for us to find the diameter at node 7 is going to be left plus right, which is 1 plus 1, which is 2. So this 2 is greater than 0. This will be placed as 2. Now the maximum at 7 will be the maximum between 1 and 1 plus 1. So this will return the value of 2. Now for 2 will be the maximum between 2 will be the addition between the maximum at left and the maximum at right. But we actually don't know the maximum at right, so we have to bump down. This will be 0, but it will return 1. This would be 0, but it will return 1. This will be 1. The diameter for this will be 1, but it will return 2. The diameter for this will be 3. So this is 1 plus 2, 3. So it would replace D as 3. But what will it return? Will it return 1 or 2? It will return 2 plus 1, because of the maximum part, the highest between the left and the right, in which the parent node is supposed to follow should be 2. So it will return 2 plus 1. This will return 3. Right now, what's if this return 3? 2 will now be 2 That's the maximum in the left plus 3, the maximum on the right. 2 plus 3 is what? 5. 2 plus 3 is 5. 2 plus 3 is 5. So the maximum diameter is 5. But then what will it return as the longest part at that node? It will return 3. Because of it won't return 2 because of 2 is not the longest. 2 is just 1, 2. But 3 is, but this 3 is 1, 2, 3. So it will return 3 plus 1, which is 4. It will return 4. Now node 1 will be 4 that it returns plus nothing here is 0. It will return 0. So it will return 4 plus 0, which is 4. 4 is not greater than this. And at that point, we've gotten to the top, and the depth size we have returned. So we just need to return d, and d is equals to what? D is equals to 5. So at this point, our answer is 5. Yeah, so that is how we solve it. Can I pause?